Example 10.4 is going to give us some practice with the chain rule. So we have W, a function of x, y, and z, and x, y, and z are further functions of two variables r and s. I want to differentiate W with respect to r, and I also want to differentiate it with respect to s. So let's go through this. I'm going to transfer everything over to a different sheet of paper, and here we have it. So the chain rule tells you that as you differentiate, you just need to connect your variable of interest to the variable that you want. If I want to connect W with respect to S, well, W depends on X, Y's, and Z's. So I'll differentiate W with respect to X first, and then I'll multiply the derivative of X with respect to S. Now you can kind of see that that cancels with that, and I'm left with the derivative of W with respect to S. I'm left with what I want. Right, but W doesn't just depend on X, it also depends on Y. So we'll differentiate W with respect to Y, and then differentiate Y with respect to S. And W also depends on Z. All right. So the derivative of W with respect to X, that's just a 1. The derivative of X with respect to S, that is a, what are we going to get there? A minus R over an S square. The derivative of W with respect to Y is a 2. The derivative of Y with respect to S is 1 over S. I don't like that, parentheses. The derivative of W with respect to Z is 2Z. And Z with respect to S is 0. Z doesn't depend on S. All right, let's just clean this up a little bit. We get a minus R over S squared plus a 2 over S. Cool. So let's find the derivative of W with respect to R. It's the same deal. Differentiate W with respect to what W depends on. W depends on X. And then you can connect X to the variable that you want, R. W also depends on Y. Oops. And W also depends on Z. All right, now we already know these derivatives from W. Right? The derivative of W with respect to X, that didn't change, it's still 1. The derivative of W with respect to Y is still 2. And the derivative of W with respect to Z is still 2Z. But now X, right, because W still depends on X, Y, and Z in the same manner. But now we're differentiating with respect to R, and X and R have a different relationship than X and S did. If I differentiate X with respect to R, I end up with an S to the minus 1. If I differentiate Y with respect to S, I end up with a 1 over S. Oh, I'm sorry, I need to differentiate it with respect to R. If I differentiate Y with respect to R, that gives me a 2R. And differentiating Z with respect to R gives me a 2. Okay, so I'm going to get 1 over S plus 4R plus 4Z.